Alrighty, so welcome to your test one solutions. Now, after thinking about it, I decided that I will only make four free response questions with a bonus, just to give you the most time to finish. So instead of five free response questions, there will only be four on your test. So here's your video solution for the test review. Now, note that the problems that were generated for me might not necessarily be the ones generated for you, so keep that in mind. But you can use it as a rough guide. So let's go ahead and get started. Okay, so for the graphing questions, we've seen this one before. Now, just to let you know, don't worry about this question number 5 business. You might see a question 1, question 2, question 3. Some of the questions I'm pulling directly from your quiz, from your self-check, so that's why there is a question 5 there. So disregard that. But let's see. We got a block on a surface inclined at an angle above the horizontal. The velocity, v, and acceleration vectors are shown. Which of the following best describes the motion of the block at the moment shown? So the velocity will always point in the direction of the object's motion. And let's see. So the velocity is pointed up the ramp. The acceleration is pointed down the ramp in opposite directions. So we can say that the block is moving up the ramp. Now, since they are in opposite directions, the velocity and acceleration vectors, this thing's going to slow down. So it's moving up the ramp and slowing down. So B. Now, you might get a version of this where they are both in the same direction. Remember that an object will always speed up when the velocity and acceleration vectors are pointed in the same direction. Okay, so question number 2. Which object has the lowest velocity? Well, we know that velocity is the slope of the position versus time graph. So this question is asking for which object has the lowest velocity. So we're looking at the least steep slope. So that is going to be C. So the object that is going the slowest is C. The object that is going the fastest is A. Why? Because it has the more steep slope. All right, so I got a car speeds up while moving away from the origin. What do the velocity and acceleration graphs look like? So let's just, we can draw a position versus time graph here if we want. So there's 0, position, X is in meters, time is in seconds. So if it's speeding up, this thing is going to be increasing exponentially on my position versus time. So if I'm speeding up and moving to the right, I want to take the slope of this position versus time graph. So it is going to have some type of linear increase. So the slope of this is going to follow the y equals mx plus b, or the equation of a line. It's going to have a linear trend. It's going to be linearly increasing. So let's see. The only ones that are linearly increasing, it looks like we got C, B, and D on my velocity versus time graphs, these green curves here. Now, what does the acceleration graph look like? Acceleration versus time. Well, that's going to be the slope of our velocity versus time graph. And so let's see. I look at these and say, well, if my position versus time is increasing exponentially and my velocity versus time is increasing linearly, then the slope of my velocity versus time graph is going to be my acceleration. So acceleration is the slope of velocity versus time. So if my velocity versus time graph looks like that, then my acceleration versus time graph is just going to be some constant. Positive. So it looks like the only one we got there is B. So you can see we have a linearly increasing velocity and a positive constant slope for acceleration. All right, so the next one, what describes the object, what the object is doing in part B of this graph? Well, we got to ask ourselves, what am I given? What am I looking at? So I'm looking at a speed versus time graph, or velocity versus time graph here. So in B, part B, let's see, from 10 seconds to 20 seconds from this interval here. Well, the velocity isn't changing. The velocity is constant. So we're driving with the cruise control on. So we are going to be moving with a constant velocity. Now, the next problem, here we got, the Michael Jordan problem. Let's see. So Michael Jordan can jump to a maximum height of 4 meters above the ground. What must have been his initial velocity to reach this max height? So let's see. We can draw a picture. We can write what we know. Let's just go ahead and do that. Velocity initial, velocity final, acceleration, delta y, my displacement, and my time. So let's go through here and see what we got. So I just listed my 5 variables. So it could jump to a max height of 1.4 meters. So my delta y is 1.4 meters. And I know at this max height, so at the apex of its motion, the final velocity of the object must be 0 meters per second. Like, that's the definition of the apex. So my final velocity is 0 meters per second. And acceleration, gravity's pulling down on him, so it's going to be minus 9.81 meters per second squared. So we want the initial velocity. So I didn't mention anything about time. I don't have a question mark next to it. I don't have any type of numerical value. So that's going to be the variable that doesn't make me happy. So I'll go to my formula sheet and I'll say, well, which one doesn't have anything to do with t? And so that's going to be equation number 4. And velocity final squared equals velocity initial squared plus 2 times acceleration delta y. And we want the we want the initial velocity. So let's go ahead and solve for it. So my final velocity is 0. So I got velocity initial squared plus 2 times acceleration delta y. So let's solve for that initial velocity. So let's take this whole term here and we will subtract it over to the left-hand side. So we're going to be left with velocity initial squared is equal to minus 2 times acceleration delta y. We solve for the initial velocity by taking the square root of both sides, minus 2a delta y. And this is going to be my symbolic solution. And so we can solve numerically here. So velocity initial is going to be equal to the square root of 2 times minus 9.81 meters per second squared times my max height of 1.4 meters. So let's see what we get. I'm just going to do it along with you in the calculator. So times 9.81 times 1.4. So I'm getting 5.2 meters per second. So let's see. Velocity initial was equal to 5.2 meters per second. Now, there's my numeric solution with correct units. Make sure on your free response that you do that. So what did I do? I went back through. Yes, I could draw a picture, but I just wrote my steps and then solved symbolically. So I'll be looking for what equation did you use? I'll be looking for your symbolic solution, and I'll be looking for your numeric solution with proper units. Okay, so next question. If an object is only under the influence of gravity, then the object is in free fall. That is true. We're going to say that the acceleration for any object that is in free fall here on the Earth is negative 9.81 meters per second squared. So that one was a quick one. Let's see. What about the next question? Okay, let's see. We got a rocket-powered sled is accelerated from rest to a final velocity of 444 meters per second in 1.83 seconds. What is the acceleration of the sled? Okay, so let's see. We got accelerated from rest to a final velocity of 444 in 1.83 seconds. We want what is the acceleration. So let's go ahead and write our variables. Velocity initial equals velocity final equals acceleration equals delta x equals and time equals. So let's see. Let's go back through our list and populate this list. So we know it starts from rest. So my initial velocity is 0 meters per second. My final velocity is 444 meters per second. My acceleration, I don't know the acceleration of the sled. That is what it is asking me to find. And I know my time is 1.83 seconds. So I don't know anything about my displacement. So let's see, we want the acceleration. So I don't know anything about my displacement. So I'm going to use the equation that doesn't have a delta x in it or a delta y in it. So that's going to be equation number 1. Velocity final equals velocity initial plus acceleration times time. And I want acceleration, so let's go ahead and solve for it. So acceleration is going to be equal to velocity final minus velocity initial divided by my time. So let's see. What do we get here? Here's my symbolic solution. That's fine if you want to leave it like that. You can make that initial velocity 0 if you want. It's just 0, but I will accept this anyway. So acceleration is equal to my final velocity, so 444 meters per second, minus my initial velocity, which was 0 meters per second, divided by the time that it took, 1.83 seconds. So my acceleration is going to be 444 divided by 1.83, and that is going to be 243 meters per second squared. 243 meters per second squared. So there's my answer, and look, there it is right there. Alrighty, so next question. A car starts from rest and accelerates uniformly over a time of 5 seconds for a distance of 30 meters. Oh, we got a lot of find the accelerations here. These are set to random, so you might get similar problems, you might get different ones, but the process is all the same. So a car starts from rest and accelerates uniformly, I don't know how much, over a time of 5 seconds over a distance of 30 meters. Determine the acceleration of the car. All right, so the next thing we do is just write what we know. So velocity initial, velocity final, acceleration, delta x, and my time. So I just list my 5 variables that are on my formula sheet. And this is step 2. And remember, on a free response, just this part alone is worth 2 points. So let's see. Starts from rest. Initial velocity is 0 meters per second. We don't know the final velocity. We don't know the acceleration. That is what we are asked to find. Distance of 30 meters in a time of 5 seconds. So I know nothing about my final velocity. So there's an equation that doesn't have a final velocity, anything, doesn't have a smiley face in it. That's going to be equation number 2. So that says that my displacement is equal to my velocity initial times time plus 1/2 at squared. My initial velocity is 0. So this is going to be the equation I use. So my initial velocity is 0. So delta x is equal to 1/2 at squared. And let's see, I want acceleration. So let's solve for a. So we get a is equal to 2 times my displacement divided by my time squared. You'll get really good at doing this algebra. I promise. It just takes practice. I know you can do it. All right, so now let's solve numerically. So acceleration is equal to 2 times my displacement. So that's 30 meters divided by my time squared. So 5 seconds squared. So let's see. We got 60 meters over 25 seconds squared. Oh, look, my units work. Meters per second squared. So 60 divided by 25 is going to be 2.4 meters per second squared. Always make sure you put your units on your final answer. Remember, on a free response question, correct units is worth 1 point. All right, and finally, oh no, we still got 2 more problems. Let's see. Oh, we've seen this one before. A feather is initially held at rest and is then dropped on the moon at a height of 6.2 meters. The acceleration of gravity on the moon is minus 1.67 meters per second squared. It's pointing straight down, just like the gravity on Earth. Determine the time for the feather to fall. Okay, so let's see. We go back through. We find what we know is initially held at rest. There's my velocity initial. We know its displacement is minus 6.2 meters, and we know A, and we want to find the time. So let's just make our variable list, velocity initial, held at rest. Don't know anything about our final velocity. It's not asking us to find anything about it. My acceleration is going to be minus 1.67 meters per second squared. And velocity initial, velocity final, acceleration, we got my displacement. Now, be very careful. This displacement is down. So it's going to be minus 6.2 meters. And we want time. So we got to solve for time. I don't know anything about the final velocity. So I'll use equation number 2. Which says that delta y equals velocity initial times time plus 1/2 at squared. My initial velocity is 0. Delta y equals 1/2 at squared. And we want time, so time is going to be equal to the square root of 2 times delta y divided by a. Here is my symbolic solution. So make sure you box the equation that you use, box your symbolic solution, and now we can solve numerically. So time is equal to the square root of 2 times minus 6.2 meters divided by my acceleration, minus 1.67 meters per second squared. So my meter is going to cancel. I got second squared in the denominator and move it upstairs. So it's square root of second squared a second. So my units are going to work. Now, here is a big clue. If I forgot to make that 6.2 meters negative in Desmos, it will say undefined because you are trying to take the square root of a negative number. If you get an undefined answer in Desmos, that means you probably missed a negative somewhere. Generally, it's here on this displacement. So let's see what we get. The square root of 2 times 6.2 divided by negative 1.67. I get 2.7 seconds. Box your final answer. Be proud of it. Make sure you got your units and you will be good to go. Okay, looks like we got one last question here. So a skydiver is initially at rest as about to jump from a high-flying helicopter. There's no air resistance. What would their velocity be after falling for 13.6 seconds? Okay, so let's see. We go back through initially at rest. What would the velocity? So we're solving for velocity final after some time. So this is here on Earth. So we got velocity initial is 0 meters per second. Velocity final. That's what we're being asked to find. Now we got to be very careful. Velocity here is underlined. So my velocity, so I'm falling down. Remember, everything up and right, positive, left, down, negative. This velocity is pointing down. This better be a negative number. Now, if the question asks for what was the skydiver's speed, that's the magnitude of the velocity, the absolute value. So that would be positive. But here it's asking for velocity, which is a vector. So direction definitely matters. So we got an initial velocity, final velocity. Acceleration is minus 9.81 meters per second squared. And we want, there's how far, there's my displacement and my time. So that's 13.6 seconds. Now, I don't know anything about my displacement. So we're going to use an equation that does not have a smiley face in my displacement. That is equation number 1. So equation number 1. Velocity final equals velocity initial plus AT. And my initial velocity goes to 0. So velocity final is equal to AT. Velocity final is equal to minus 9.81 meters per second squared times my time, 13.6 seconds. So let's see, 13.6 times 9.81 is going to be minus 133.4 meters per second. So there's my final answer. Now remember, because it's asking for velocity, this velocity is pointing down. It's falling down. Everything up and right positive, left down negative. This negative is crucial. Don't forget it. There might be a question that asks for what is the speed. There might be a question that says what is the velocity. So you got to be very careful when you read your problems. But if you practice these, I know you're going to do great. So with that, as always, happy solving.